All right, this video is to help people with the IXL about solving systems of equations by graphing. So we're going to start by graphing each equation. So remember, currently this is in slope-intercept form. Y equals mx plus b. I know it's in slope-intercept form because the y is isolated on one side of the equation. So that means that I can look at this last number that does not have a variable next to it, and that's my starting point. So positive 2. And then I move with the slope. So it's negative 2 over 3. So rise over run, right? So the top number tells us how far to go up or down. And since it's a negative number, I'm going to go down 2. And then the bottom number tells us how far to go to the left or right. There's only one minus sign here, which means only one of the numbers in the fraction is going to be negative. So I'm going to just put the 2 as negative, and then the 3 will be positive. So from here, I'm going to go down 2, and then 1, 2, 3 spaces to the right. Now for the next equation, my starting point is negative 5 on the y-axis. Y-intercept, y-axis. And then my slope is 1 over 2. So I go up 1 space and 2 to the right. Now my what is it called? My solution is, where do the lines cross each other? Where do they touch? And they touch where x is equal to 6 and y is equal to negative 2. So that's what my answer is. So the first number here is always the x value. Second number is always the y value. Okay. For one like this, negative x, think of it as an invisible one. So instead of it being just negative x, it's negative 1x for that slope. So I'm starting first at the 3, and then the slope is negative 1. So when I think of that as a fraction, it's negative 1 over 1. So I'm going to go down 1 space and 1 space to the right. For the second one, my starting point is at negative 5. And then my slope is 5 over 3. So I go up 5 spaces, 1, 2, 3, 4, 5, and then 3 spaces to the right. And they meet right here on the x-axis. So when x is equal to 3, y is equal to 0. So 3 comma 0. Okay, let's go to a different equation. Just FYI, there's no number being added or subtracted here. So that means that you start at 0. But I want to go to a different problem. Let's see. Nope. Oh, okay. Let's see here. So negative 4, and then up 1 over 3. And then the second one, start at positive 1, and then up 2 over 1. They meet here. So that's when x equals negative 3, y equals negative 5. Negative 3, negative 5. The challenge zone. Okay, this is what I wanted you to see. Sometimes our equations are not in slope-intercept form to begin with. So we need to change it to be in slope-intercept form. So I'm going to solve this equation for y, because if I graph it like it is right now, like if I start at 2 and then I do up 1 over 1, that's incorrect. So x plus y equals 2. So in order to solve for y, I'm going to subtract x on both sides. So I get y equals 2 minus x. It is now pretty much in slope-intercept form. The number that's being added or subtracted by itself, there's no variable next to it. That's my starting point, so I am starting at 2. But my slope is not positive 1. My slope is negative 1 because this x is being subtracted. So I'm going to think of this as negative 1 over 1. So I'm going to go from here down 1, 1 to the right for that first equation. Now the second equation is in slope-intercept form already. So let me go there. So you start at 3, And then I go down 2 since it's a negative 2. 1, 2, and then 1 to the right. And the equations touch each other at positive 1, positive 1. When x is 1 and y is 1. Okay, I hope that helps.